Okay, let's just dive right into this. Welcome to The Explainer. I'm your host, and today I'm stepping into the role of your master coach for a highly requested, really intense deep dive session. We are going to completely decode one of the most notoriously tricky sections of the entire Cambridge AS and A-level Mathematics 9709 syllabus. Yep, you guessed it. Section 3.7, Vectors. Specifically, we're heading into the absolute battleground of parallel, intersecting, and skew lines. Now listen, whether you are currently sitting for your AS level or you're gearing up for the full A-level papers, this explainer is designed to be your ultimate masterclass. We are going to dissect complex questions, we're going to manage time metrics under extreme exam pressure, map out incredibly clear structural frameworks, and apply very specific Cambridge answering strategies. Why? To secure you those absolute top-tier mark bands.
15%. I really want you to let that number sink in for a second. 15% is the approximate amount of your total exam marks that this specific vectors topic can account for in your 9709 mathematics papers. Let's be real, 15% is not just a fraction on a page. It is literally the absolute difference between scoring a B and an A, or an A and a clean A star. Yet, year after year, when I look at the Global Examiner reports, they tell us the exact same story. Students are leaving these marks on the table. And you might be wondering why. Well, it's mostly because they treat vectors as a pure robotic calculation exercise rather than constructing a logical mathematical argument. Today we are changing that completely. I'm going to show you exactly what the chief examiners are actively looking for on your script. To unlock those marks, we are following a crystal clear blueprint today. First, core vector principles. Second, the technical methodology. Third, evaluation and examiner traps. And finally, an ultimate strategy recap.
Let's kick things off with Section 1, Core Vector Principles. Mastering the foundations.
Okay, so we really need to master the foundations before we can even think about building the house. The entire theoretical architecture of 3.7 vectors rests on precise definitions and causal relationships. You see, under extreme exam pressure, candidates constantly struggle with distinguishing between key vector terminology. Let me paint a picture for you. Imagine two typical students in a shared study suite preparing for this exact exam. We'll call them Alex and Sam. Now, Alex is your classic memorizer. Alex overloads paragraphs with raw factual definitions, but totally fails to provide any deep analysis. Alex knows the definition of the direction vector, but struggles to use it. On the other hand, you have Sam. Sam is a fast writer who constructs these highly persuasive, long mathematical arguments, but completely misses the explicit restrictions set by the question's command words. Both Alex and Sam are going to lose marks. Why? Because if your baseline definitions are shaky, or if you aren't answering the specific command, the examiner's grid immediately limits your maximum possible score, no matter how flawless your algebra is later on. Top-performing students do not just memorize definitions like Alex, they demonstrate what we call connected understanding. It is the crucial difference between merely stating that a skew line doesn't intersect or run parallel, and actually constructing a persuasive, analytical argument that mathematically proves it. You absolutely have to bridge exact textbook knowledge with analytical execution. It's about transferring those fundamental principles to totally unfamiliar contexts across distinct cognitive domains.
Let's look at this exact quote pulled straight from the Principal Examiner report. It says, "Candidates referencing cross-topic connections achieve significantly higher marks." This is huge. The crucial point here is that vectors do not exist in a vacuum. When an exam asks you to find the shortest distance between two skew lines, you aren't just doing basic vector arithmetic. You are actively applying geometric logic, spatial reasoning, and sometimes you're even linking right back to coordinate geometry concepts. Integrating these vector principles with other syllabus areas is, without a doubt, the ultimate secret to maximizing your mark yield. It essentially proves to the examiner that you are a comprehensive mathematician, not just a human calculator.
Moving right along to Section 2, the technical methodology, securing process marks.
Now we're getting into the technical application. This is exactly where we secure those precious process marks. Cambridge examiners heavily award marks for logical, evidence-based processing. We call this the method mark strategy. It means that even if your final answer is slightly off due to a tiny arithmetic slip under pressure, a flawless methodology ensures you still capture the vast majority of the available points. Here is the exact step-by-step procedural framework you need for a high-tariff question, like determining whether lines L1 and L2 intersect, are parallel, or are skew. Step 1. Deconstruct the question. You have to decode the command word. Let's go back to our students Alex and Sam. If the command word is determine, Alex might just guess, but determine means we need a conclusive mathematical proof. If the question says show that, the outcome is already known, and your job is purely the algebraic proof. Misinterpreting this triggers an immediate penalty. Step 2. Extract relevant data. Pull the position and direction vectors directly from the line equations. Step 3. Select your analytical framework. Don't just wing it. First, check if the direction vectors are scalar multiples to test for parallel lines. If they aren't, you move to equating the x, y, and z components of the two lines to create 3 simultaneous equations. Step 4. Execute with clear notation. Solve 2 of those equations to find your parameters. Step 5. Present with correct terminology. You substitute those parameters into the third equation. If it balances perfectly, boom, they intersect. If it doesn't balance, they're skew. It is a highly logical, step-by-step machine.
And we need to be absolutely 100% clear about how you present this math on the page. Presentation follows strict, non-negotiable conventions. Proper headings, correct terminology, appropriate formats, and crystal clear annotation. When you are writing out your vectors, are you using the column vector format clearly? More importantly, are you distinguishing between the parameter for line 1 and the parameter for line 2? I cannot even begin to tell you how many times a chief examiner looks at a script where a student has used the symbol lambda for both entirely different lines. That is an immediate format failure. You absolutely must convert your mathematically correct processes into actual recorded points by making it literally impossible for the examiner to misunderstand your logic.
Let's shift to Section 3, Evaluation and Examiner Traps, where marks are lost.
We rigorously scanned the most recent principal examiner reports, and I want to rapid-fire the top 3 mistakes that trigger massive point drops. Think of this as a Spot the Examiner Trap workshop. Trap number 1, using the wrong approaches for the context. For instance, imagine trying to find a point of intersection by equating the lengths of the vectors rather than their specific directional components. It is mathematically nonsensical for the context of the question, and the examiner will stop reading. Trap number 2, format and presentation failures. We just touched on this, but it includes messy notation, unlabeled parameters, or dropping negative signs during a basic algebraic expansion. Trap number 3, providing generic answers. In the world of vectors, this usually looks like a student doing all the brilliant math, finding that the simultaneous equations don't balance, and then they just stop. They leave the examiner totally hanging without explicitly writing, therefore, the lines are skew. I want you to pause for a second. Do a mental check right now. Think about the very last vector problem you solved. Did you explicitly state your final conclusion and link it directly back to the original question? Or did you just double underline a random number at the bottom of the page and move on?
Strategy check. Before we unlock this top band paragraph structure to help you absolutely crush your upcoming exam sessions, I need to make sure your revision feed is perfectly optimized. Take a second right now to subscribe to Ace the Exams at the handle @AceTheExams, and make sure you enable all notifications so you never ever miss our weekly Cambridge exam breakdowns, no matter if you are sitting for IGCSE, O-levels, or AS and A-levels. Okay, let's get back to it. The classic trap is writing generic, unlinked answers. To achieve that elite top-scoring standard, you must justify your evidence contextually. Remember Alex and Sam? They hit a structural roadblock where their mathematical evidence failed to link back to their main thesis. To fix this, you deploy a universal structural matrix, the PEEL framework. That stands for point, evidence, explain, link. Let's apply this to a complex vector's conclusion right now. Point: the lines are not parallel. Evidence: direction vector A is clearly not a scalar multiple of direction vector B. Explain: furthermore, setting up simultaneous equations yields totally inconsistent values for our parameters lambda and mu, meaning no single point in 3D space satisfies both line equations. Link: therefore, because they are not parallel and they do not intersect, the lines are explicitly skew. Do you see the difference? By structuring your response line by line this way, you engineer a flawless, top-tier response block that examiners are literally desperate to reward.
To universally avoid falling into those traps, you have to employ the deconstruct, solve, evaluate framework. It's a 5-step lifesaver. Step 1, identify the given information. Think of this as the visual data scan. If you have a complex vector equation in front of you, give yourself a strict 60-second mental countdown to extract the core parameters, the position and direction vectors, before you do anything else. Step 2, break it into highly logical steps. Step 3, solve it systematically, line by line. Step 4, check for reasonableness. This is huge. If you calculate the shortest distance between two skew lines and your result is a negative number, your spatial reasoning should immediately sound an alarm. Distance cannot be negative. You've made an expansion error, catch it before the examiner does. Step 5, make justified recommendations or conclusions based strictly on the math you just proved.
And that brings us to Section 4, the ultimate strategy recap. So, what are the absolute core takeaways from today's session? I'm going to distill this entire masterclass into 3 universal Cambridge operational rules. Rule number 1, The 3-step question scan. Decode the command word, extract your vector parameters, and deliberately select your framework before you ever pick up your pen. Deconstruct precisely. Rule number 2, the marks per minute formula. You have to allocate your time based on the tariff. If proving lines or skew is worth 6 marks on the paper, you have roughly 6 to 8 minutes to execute those simultaneous equations. Do not get bogged down, maintain your pacing. Rule number 3, the post-writing compliance audit. Evaluate constantly. Review your own checklist as if you were the examiner. Did you use proper notation? Did you explicitly answer the specific command word asked? If you apply these 3 rules and rigorously, consistently practice past papers, you are going to build that vital memory muscle.
I want to leave you with one final provocative thought. We know for a fact that cross-topic connection is the absolute hallmark of an A-star candidate. So, how will you connect your vector frameworks to the rest of the 9709 syllabus to secure that top band today? Seriously, think about how the logic of vectors relates directly to calculus or trigonometry in your very next study block. Before you go, drop a comment below and share exactly which Cambridge subject and level you are preparing to conquer next, whether it's IGCSE, O, AS, or A-level. I read them all. Let's keep this incredible momentum going. Dive into those past papers, apply that Peel framework, and I will see you in the next masterclass.